the work kind of flows in here. Just you have to make sure we see it, especially when we get to graphing functions. We need to graph everything. And the kids go crazy when they hit calculus, and it literally takes them 3 pages to do one problem. But if you keep your work organized and you follow it step by step, you'll be fine. And in the beginning, I'll be a little bit easier. I like to say, make sure you put this down, make sure you write this down. Ms. Fernandez and I do the test together, we do the keys together, and when we do a key for a problem, say this is one of your test problems, if this is worth 6 points, we'll go by each step. We need to see this as 1. We need to see this as 1. We need to see this as 1. We need to see some kind of a graph method. So they're all broken down by points, so that work has to be there when we check them off. I'm a little bit easier grading than her, but still that work has to be there. So gather it to one side. You're going to take anything that's positive, factor it. These are your critical values. These you need. Whether you put it on a number line, whether you put it in a graph, either one of these, not both, either one of those. Do I need to see this in here? No, but I do need to see where it is positive, where it is negative, where it is positive. If you superimpose your parabola on here, even better. Okay. And then your final solution should be an interval notation. An or statement, make sure you break it down. If it's including the 0, make sure you have a hard bracket. If you have any questions, stop me, and we'll move along. For you guys, Noah and Danielle, neither one of you were here. What we did was we take an inequality. We get everything to one side, set it to 0, kind of keep your inequality, factor it. At this point, you're kind of setting this equal to 0. You're finding your critical values. Set it equal to 0, find your critical values, put them on a number line. The number line is part of your xy axis. It's just the x-axis. Because your roots, your solutions, your zeros fall across the x. So that's the only part you really need. If you want to give me a full one, that is fine. We take this and you can put it in your y1. You can check values in all 3 intervals, to the left of -1, in the middle, to the right of 7. Or you can take the shortcut. This is a parabola that opens up with these roots. So it's got to go like this. So anything above the line is positive. Anything below the line is negative. Anything above the line, positive. So you want all the ones that are less than 0, you want the negatives. You want this in here. Now, last year when you did these on the algebra books, in the algebra books, they tend to shade in like this. It's probably what would look familiar. I don't shade, but I just use this part. We don't shade anymore in these. And then you get your answer. Write your final answer as interval notation. So I find it easier on a number line than to make my parabola. If you find it easier to graph it and look at your table, whichever you find easier. But I want some kind of test in here. Alright, again, get everything to one side, factor, and they won't always be quadratics. They could be cubing. We did a cubing function yesterday. They could be a cubing function. We'll take a look at cubing functions in the next unit. We'll start doing more functions graphing. So this one, find your critical values, test. Your parabola is opening up. It's passing through the points. So you want your positives, your negatives, your positives. And in this case, we want negatives. Good. Questions at all so far? No? You're okay? Okay. this is a cubing function. Factor out the x. Find your critical values. Again, you have 3. Your highest exponent is 3. You should have 3 zeros on this. Because it's cubing, the left side is going down, the right side is going up. So, graph it, see what it looks like when you graph it. Test the intervals. I should have put the graph right on top of that. These algebra kids take the mess like these calculators. Alright, so because it's going down here, up here, it's got to come through like this. Tests. Sometimes what I usually do is I usually put the negatives down here, the positives up here, the negatives down here. You want all the positives. Be careful when it's equal to 0, that if there is a 0, you include the 0. And give me your solution set. This one again is a 4th root. It's got a double in here. This, I think this graph, I don't know where this graph came from. This graph is crazy. This calculator is weird. I don't know where that graph came from. So graph it, check it, and get your solution set. You want your negatives this time. You can tell when these algebra kids are bored. There's all kinds of stuff in these Y1s. Yeah, sometimes not such nice stuff. Then they turn every plot on. This is the graph. You turn all your plots on. Alright. Okay. So we're good? Questions? Any questions? And 6. It is. It's included in the solution from negative infinity to 3. What happens is this. When your graph goes like this, all of these are negative up to here, up to 3. So we can use all of these. Because the 0 is a closed 0, we just negative infinity to 3. If this was an open, then we would have to go from negative infinity to 0, jump over 0, and go to 3. Good question.